What? All right, we're gonna start off with lecture just in a second here. So if you want to be closer, you can come closer. If you're good back there, it's okay with me, but I know it's sometimes hard to see. Great. I'm just gonna check in, see how Calgary's doing. Hey guys, let me know if you can hear me and if the audio is like good. Great. Predictive answering. So I hope you guys had a good weekend. And we're into the front end week. So you guys already had a bit of a success making your first web application last week with Tiny App. I saw a lot of your projects here. They're looking really good. I'm sure they were looking awesome over in Calgary as well. And today we get to move on to, I know the screen's out, it'll come back, Calgary. Or it should. There you go. So today we get to move on to the next project that we're making. It's a Twitter clone. And the workflow will be similar to last week, except there's a lot more focus on front-end development for this week. And what does that mean? That means we're thinking more about how the application looks, what the UI is, and we're focusing on things like CSS and HTML. And that's our focus on today's lecture, just a nice intro to CSS. We have kind of a lot of stuff to cover today. So my apologies if we're not going into like super depth on anything in particular, but it's a chance to ask questions, and you know, if you still have anything unclear afterwards, make sure to keep me in the loop and update me on any questions. I feel like this is my experience when I do a lot of CSS stuff. I'm sure it's going to be your experience throughout this week. Especially when you're starting off, CSS is just very finicky. It's a lot of just poking things and trying to get them to work, changing one small value and having everything break. It's less of a science, more of an art, I guess. So it'll be frustrating, but you know, you'll start to get into the swing of things for sure as it goes. Specifically, we're going to be looking at briefly just what semantic HTML is. Let's get this. Hey, why is it not? There we go. We're going to look at some CSS stuff for sure. We're going to look at something called the reset or normalize. We're going to look at the box model. This is a part of CSS. We're going to look at different properties for CSS, block level elements versus inline, position elements, things like that, float, and then we're going to close on thinking about what does CSS look like today, or what is modern CSS as it is. The theme of this lecture you're going to find is that we are kind of looking at CSS historically, or we're looking at what were the foundations or principles that CSS was made upon. Some of those things are not as heavily used today as they would have been 10 years ago, but they are fundamental to understand before we move on to some of the more modern CSS features, just so we have that baseline and we understand maybe older code and the reasons for certain layouts and things. But before we jump into any comment or content, just a brief touchstone on how we're doing with the bootcamp. At this point, we're probably settled into the flow of things. Maybe we're questioning what we got ourselves into. The pace is undoubtedly feeling very fast, and this is just a reminder that it's going to continue very much in that manner. More new concepts every week, more chance for you to explore new material. But starting now and going forward, and you've probably already noticed it to a degree, the content is going to be less and less hands-on. And this is not by laziness, this is more by design, because part of being a really good web developer is having the skills to research and come up with solutions on your own. So the course material is going to be less do X, then do Y, and more you have this problem, how are you going to solve it? Here are some tools that might be helpful. It's not going to jump right to that, starting today, but you're going to notice a move towards that direction. Let's just get a brief look of the project you'll be working on this week. So this is Tweeter. Like I said, it's a Twitter clone. This is kind of the base white label Tweeter. People often experiment with this, add a little bit of pizzazz and style based on their own experience with the application. But from a base functionality standpoint, I can toggle the compose tweet element. I can make a new tweet. What up? It's Monday. Sad face. Oh. I hit tweet, and the whole list of tweets that we have updates with my new tweet. We've got cool information like time since the tweet was tweeted. So this happened a few seconds ago. This one was an hour ago. I was testing it. This one was 4 years ago, apparently. On hover with these guys, we have some nice kind of animation effects. This button appears and brings us back to the top. And also part of this project is making it responsive. So hopefully, if I make this different sizes, we see the layout responds according to the space I have on my screen. So all things that you'll be creating and working with this week. And yeah, unlike with Tiny App, you'll be the one writing the CSS for how to get this header to work, the CSS for how to make this nice little tweet box. All of it will be you. Cool. We kind of went over this. I was just saying we're focusing on things like CSS box model, which is a foundational thing to CSS. It might not be something that you heavily rely on for your layout once you find some modern CSS tools, but it's fundamental to know before we look at the new stuff. We're not going to be looking at today things like CSS frameworks, something called Sass. Sass in particular, you'll be touching on, I believe, on either Thursday or Friday. And other modern CSS features we're not going to be looking at. We're also not focused on HTML. We're going to do a brief kind of intro to what semantic HTML is. And I know you haven't had like a lecture on HTML, but it's your chance to research a little bit. On a base standpoint, HTML stands for Hypertext Markup Language, and it is just defining the layout or the structure of your web pages. You're not like brand new to it. You've seen it. You maybe haven't had to write the markup yourself, but we have tags that kind of break up our content into portions. I like to think of them as just like little containers that you usually either put text, image, like video, any media inside, and it breaks apart your web page so that you can not have just a straight continuous line of content. It also very much helps with styling in CSS, and we'll see how the two link together today. But the first thing we want to think about is semantic HTML is the idea that an HTML tag should be expressive about what content it holds. And some semantic HTML tags are newer, so there are non-semantic versions. For example, to make some text bold, we could use a strong tag or a B tag. Functionally, they're both very similar, but obviously one of them has the advantage of more accurately describing what the tag is doing. If I'm using this strong tag and I see some text inside of it, even if I don't have like a depth of understanding of HTML, I can probably intuit that, oh, that's going to make this text more important or bolder or stronger, however that represents itself. So for instance, I have this small, poor layout here, my upcoming website about rocks, and I have the content just divided by some divs. So I have, rocks here. Maybe this is a title. I have another big div. I have something that says rocks are cool. I have this little emoji here representing maybe like an image. For me, making this layout, I maybe have an idea as to what the structure should be or what these divs represent. Like to me, this is maybe a header, and then I'm saying, okay, everything in here is the content. This might be like a subtitle. This might be like I said earlier, an image or a figure, and then this would be a footer. So internally, I know what it means, but I'm working with other people, or when you guys are looking at it, it probably makes no sense. But by using semantic HTML, we have the option to add some more meaning to this layout. So an alternative would be something like this, where I use a header tag. I have an article for my content. I have this kind of image enclosed in a figure tag. I could have probably taken this title here and used like a header tag, so or an H1, H2 for different titles. And then finally, I'm closing it with a footer. In terms of functionality, these semantic elements that I've used here, header, article, figure, footer, function the same as a div. And we'll look at what a div means in terms of displaying content on the page. But functionally, these two are the same. It just allows us to be more descriptive in what the content is doing. Even if you don't have my context, even if you're not the person who created this layout, you can look at this and have an idea of what it's trying to convey. So do yourself a favor, get a little bit familiar with semantic HTML. You don't need to memorize all of them. Tags. You can always do a quick search. Maybe go to W3 schools. Here's a small list of semantic tags we have. Things like article, aside, details, fig caption, figure, footer, and so on. All of these tags are more descriptive than using a div. And here we see kind of a visual representation of how each of these tags could break up a layout for a web page. So nothing super revolutionary there. Let's just use tags that make it easier on the reader. Tools. So the biggest thing you're going to depend on this week, the thing that's going to be so helpful, is developer tools with Chrome, or if you're using another browser. Most have very similar support in their dev tools. With front-end development, this is just going to be huge for you. You've probably peeked into developer tools at this point, but let's look at this page that we brought up. And we go either right-click, inspect, or you can bring it from the more tools, developer tools, or for whether you're on Mac or Linux, you can look up the shortcut for it as well. These tools for front-end development give us a great peek into what's going on the page itself. We have all these different tabs that we can look in. You might have had more practice with things like the network and the console tab for when we're trying to find console logs from our JavaScript. The tab that we're going to be focusing on is the Elements tab. And with the Elements tab, we have the top elements kind of window here that shows the HTML for our page, and the bottom, or depending on how you have your developer tools laid out, a second window with all of the CSS that is being applied for this page. You can click on this little arrow with the square, and elements will be highlighted as you scroll over them in the page. Let's look at this. It says this is an H1. We can click on it. It will be selected in our HTML, as well as the style will be brought up in our styles tag. These are all the styles particular to this header that are being applied, and we can scroll through them. We'll dive in a bit more as to what all of this means, but this is like a lifesaver in terms of front-end development, and we'll continually use it throughout this lecture. So what is CSS? CSS stands for Cascading Style Sheets. Whether or not that's a great name or not is to be debated, but the cascading part of it, I'd like to use the metaphor of like a multiple tiered waterfall. So this is a single tiered one, but the different tiers of the waterfall are different style sources. And to get to this point, a fully styled web page, our HTML document is going to compile all the multiple sources of our styles together from one tier to the other, combining them to reach like a final pool of styles at the bottom. This is to say that there is no one single source for styles for our page. They will be coming from different locations and smartly integrated together to provide a single set of cohesive styles. The cascading algorithm determines how to find a particular value for a style. And another algorithm called the specificity algorithm decides which style will be applied to the document. So we have the different tiers of our waterfall, or the different options for applying style, are embedded styles. This is a style that we can apply at usually at the head of our HTML document between style tags. We can have external style sheets, where we link to a completely separate document from our HTML page, which has style broken up like this. We can also have inline style, where right when we're declaring a HTML element, we can give it a style attribute and declare the property and values for a particular style. So I think it's helpful if we actually look into a demo. And I have some code here that is cascade.html. So this is our HTML document. We have a head tag. This is where we include a lot of like metadata and links to external resources. I have a link to a font on this first line. I then also have a link to a style sheet called waterfall.css. And I have an internal style here. So when we were talking about embedded versus external, these are our first two examples. We have one external style sheet and one embedded style sheet. Embedded and external style sheets are very, very similar in how they function. They're both loaded once where they're included, and then they apply globally throughout the whole HTML document. Obviously, the external has some benefits in that I don't have to include more stuff in my HTML document. If I have like lots and lots of styles in here, my page is going to get really long. Following the header, we have a couple boxes. Box 1, and then inside of box 1 is box 2. Inside of box 2 is 3, and then finally box 4. And this is my attempt to illustrate the waterfall. Each of these boxes is getting style from different locations. So let's look. We have this white box being the box 1, this light blue box, box 2, box 3, and then box 4. We open up the developer tools. If I click on the outermost box, I see I am getting style here because the outermost box is a div. And the source, if I look in the top right corner of this little breakout, is waterfall.css. So this white box is getting this chunk of styles from this external style sheet. We switch over here, I can open that style sheet, waterfall, and we see right at the top, that's where the style is coming from. It also has the class 1 and is getting style from here. We could give it some new style. What's something different from font color, or sorry, color, and we'll do it a green yellow. And now the text has changed. We also notice that this text changed, and we'll look at that in a second. Going inward, our second box has styles from 2, from the same CSS style sheet. It has styles from the div. It also has style from user agent style sheet. When you see user agent style sheet, this is the base browser style sheet that is applied to every HTML markup that gets run through the browser. So Chrome has a user agent style sheet. Mozilla has a user agent style sheet. Safari, they all have this base styling for what basic tags should look like. We'll get into this a bit in detail a bit more. And then we have some more styles that are being inherited from box 1. So our waterfall right now maybe has 2 tiers. This is getting stuff from the style sheet. It's also getting stuff inherited, and it's getting something from a user agent style sheet. This outer one also had user agent style sheet stuff as well. I'll run through the next couple ones quicker. So our third box, we again get stuff from the waterfall style sheet. We're also getting something from Cascade, and this is the style stuff that we see within the HTML document here. And then going down further, our last one has stuff from something called an element style. Element style means an inline style. So our smallest box has inline style. It has embedded style, and it also has external style sheet. So this is all just to illustrate that this inner box or any HTML tag within your document gets style from all of these different sources. And it can be listed here in your developer tools, and it integrates them all together to get a specific look for your HTML tag. Again, we have element style. We have, this is from the embedded style. This is from the external style. and this is from the user agent style sheet. Just playing with a few things in the developer tools. When I highlight over different styles, I see this checkbox. This is great because I can toggle on and off different styles to see how they affect my document. So this inner 4 one, the background color is dark blue. I can just unclick this and see how it affects my application. I can come down to these other ones. I can change the font family, see how it affects. This one, because it's more general case CSS, it's for all divs, affects all of the divs. There's also one case in here where we see some style that is crossed out. This means that this style is not being applied to my document or to the element that I've clicked on in specific. The crossout means another style is being applied in, it's overrided this style here. So this has lower priority than a style, probably this one, this color snow. If I unclick color snow, we get the green coming through. So there's a lot of information. Sometimes you'll write a style in CSS and it won't show up when you refresh your page. You're like, why is that style not going? The first thing to check is to look in here and see if it's even showing up in these styles. If it's not showing up here at all, it means you probably have some syntax error or you're not including that style correctly on the code side of things. If it is showing up but it's crossed out, it means your specificity is wrong in some way or the other. We haven't looked at specificity yet, but we'll get into, for instance, why the color green-yellow is not being applied and the color snow is being applied. They're both kind of like warring out to like change the color of this text, but one is winning over the other. Why does that happen? We'll look at that in a bit. Cool. The syntax of what we're looking at, when we declare styles, like we saw here, we start with a list of what are called selectors. So in this case, the selector is div, followed by open and close curly brackets. And then we have a list of styles, which are kind of similar to objects that we've seen in JavaScript. This looks similar to like a key value pair. So key being min height, value being 200 pixels. These are our style attributes and their values, or the properties and their values. So property and value. You'll just generally get used to what properties are available over time. If you want to do a particular thing or make something look a particular way, just Google like CSS move container right or CSS bold text, and you'll start to get used to this. Another option is to have like a cheat sheet of just style properties and what they do, if you find that helpful. This is not something you have to like memorize. You'll just get more and more comfortable, and eventually you'll have a lot of them memorized. But you look this up for now on a need basis. Our selector list can be made up of elements and something called IDs and classes. IDs and classes are hooks to grab elements so we can apply style to them. They're like a label that you're applying to a particular HTML tag or element. So for example, this div has the class shaman, this div has the class rogue, and I've given both of them a class. So in my CSS, I can say only to the div shaman do I want it to look a particular way. Only to the div rogue do I want to look another way. It gives me distinction in how I style elements. Instead of saying all divs should just look a generic way, I can provide specific styling to a particular div. Classes and IDs are functionally equivalent in terms of styling. If I want to style like a header to look like this, whether I do it with like styles or classes or IDs, it'll look the same. So it doesn't help with how things look, but how they can be applied to a div or any element is a little bit different. IDs are unique. Each element can have at most one ID. So here I have class shaman, class rogue, but I could, for instance, here I have a class that is both, or a div that has both the classes box and to. So it has two classes. If I were to give this an ID of thing, I could not also give it another ID of thing too. It can only have one ID. And beyond that, I can only apply a certain ID to a single element. So this div, all of these divs have the same class box, but I could not give the same ID to more than one element. Or not so much that I cannot do that, because my browser is not going to like yell at me if I provide an ID to more than one thing, but I'm going to have a lot of internal problems in terms of how the style is being applied to my elements and other things when we're talking about JavaScript. All right. So IDs can only be applied to one HTML tag. You can only apply at most one ID to a particular HTML tag. This is how we apply them. Element can have both classes and IDs. We saw that in my CSS. And we use these IDs, these classes, and the actual tag names of HTML elements to select a particular thing in the DOM, a particular HTML tag in the browser. So I can say div, comma, dot primary. I can do div, no space primary. I can do div, space primary. And these are all going to select different elements within my markup. This first one is to say all divs, comma, and all classes that are all elements that have the class dot primary. So divs and dot primary classes. My second set of selector is divs who are also dot primary classed. So divs that have the dot primary class. This is them together. This is a div by itself and dot primaries by themselves. The last one, div space dot primary, is any element that has the dot primary class that is inside of an element that is a div. So we'll be looking at more examples of CSS throughout this lecture, and the primary ones we're going to be seeing are these two. There are a few other selector patterns for finding like a particular child, or finding just the first child, more specific things. Those can be helpful. You can look those up. These are the three that you're going to get the most use out of and that you'll see most common throughout CSS. Before we go further, any questions on IDs, classes, and selectors? Oh, yeah. Where did it? So the question was, what is this secret browser power? So the extra browser power, that's a weird word to say, that IDs have is that you can link to IDs within a page. So for example here, this is like a somewhat long page. Sometimes you'll see, actually it might even, no. Sometimes you'll see in like a really long page, there'll be a link where you can say, go to the intro section, and it won't take you to another page. It'll just jump you down to like the position where the header says like intro or something. The way that's done is if you give, So for instance here, if we went in, we grabbed, oops, this header, and we gave it an ID of anything unique, you can have a link that links to that particular part in the page. So it'll jump you down or up, depending on where you are on the page. Yeah, that's its secret power.
Earlier in the slide versus the CSS you had, each of the elements were divided by commas or semicolons. Is there like a semantic difference between those things? Comma there and then semicolon.
Here, this is a error. So yeah, it should be what we have here, semicolons. Each style property and value, you close off with a semicolon and bring you on to the next one. Commas are if you want to specify multiple values for a specific property. So in this case, font family, we're saying try and do the Roboto font. If you can't, try and use Helvetica. If you can't, use sans serif. So yeah, good catch. Let me check with you guys in Calgary. Whoa. Sweet. Yeah, if we're good, we'll continue. Calgary, if you have any questions at all, just throw them in Slack, and I'll try and keep on that. Apparently, Spotify is going. Let's see. There we go. So I'll hear your notifications. Yeah. Mm-hmm. Mm-hmm. So the question was, we saw here that we had a couple different ways of applying styles, embedded, external, and inline. And the question was, how do we determine which style to be applied over another style? If we have kind of non-overlapping styles, it's fine. They'll all just be applied. Meaning if embedded, I have something around position. In the external style sheet, I have something around the color. And inline, I have something around maybe the boldness of my text. There's no conflict there. They will all just be accepted. The problem comes if I have, I'm trying to set color in my embedded style sheet, in my external style sheet, and my inline, which one wins out? And that was what I mentioned comes up to the rule of specificity. And we're going to look at that. That is probably one of the most important questions, but it's going to come a bit later in the lecture. So great question. We're not going to dive in it just yet, but it's coming up for sure. Cool. Before we go on, let's talk about resets and normalizes. So I briefly mentioned something called user agent style sheets, and we saw it in the developer tools. All the browsers are going to apply a base set of styling to our markup, even if we don't have any styles ourselves. So if I look up user agent style sheet, this is kind of a representation of what the user agent style sheet does to our HTML. So this was probably like an H1. H1s are larger and bolder. When we make a list with list items, so a UL with LI tags, they are tabbed and they have like some bullet indicator. Normal links with HTML are blue, and then you click on them and they have that like purple visited color. They're underlined. They have a different cursor. This isn't the user agent style sheet, but it has some of the elements of it. When I scroll over it, I get the hand cursor. There's the underline. Different things like that are how each browser thinks that a certain HTML tag should look like. The problem here is that there's not a single browser, and browsers have not had the most peaceful of pasts. It is less a problem now, but particularly back in the 90s and early web development days, each browser was really competing for users and market share. And a browser would say, hey, we can add this really cool new thing that this other browser can't. And then the other browser would say, hey, we have this other thing, which made it really hard for developers because browsers were not consistent across each of your websites. You had to make sure that if you were doing something for Internet Explorer versus Netscape, you had to take that into account. So user agent style sheets at one point were more opinionated. These days they are fairly consistent from browser to browser, but there still are some inconsistencies. And to solve that problem, we need either a reset or a normalize. So a reset removes any default browser styling. It takes all the styles and sets them to a basic 0, nothing. If we looked at this same HTML document and applied a reset to it, every single thing in here would look the same. They would all just be maybe this default text here, depending on the reset that we used. We wouldn't have bold and large H1s. We wouldn't have indented and bulleted lists. We wouldn't have links that look a certain way. The benefit to that is then we can say, okay, no matter what browser I'm looking on, everything is kind of demolished, and we're starting from a base bedrock to build the styles that you want. It makes it a homogeneous visual style, and then you can decide for yourself what an H1, H2, all of these other elements look like. This is the classic reset. So it's just a big block of CSS. Here we can see we're essentially saying every single HTML tag, H1s through H6s, paragraph tags, emphasis tags, all of these give them this base nothing style. Same with some other stuff here. So resets are nice, and they've been used a lot, but there's one problem to them, and that's the idea that well, although user agent style sheets are inconsistent, they still did something kind of useful. They provided lists should look a certain way, headers should be bolder and larger font, and that makes sense to us as users. They weren't just providing nonsensical styling to HTML tags. So what if we could keep the usefulness or the layout that they were providing, but just make it uniform? And that's what a normalize does. Where reset imposes a homogeneous visual style by flattening the default styles, normalize retains many of the useful styles, but makes sure that they're consistent across whatever browser that you may use. Meaning you don't have to redeclare styles for common typographic elements, like the headers and link tags that we talked about. And on top of them, you can still change the defaults and build upon them, but you don't have to do a bunch of work just saying oh, now I need to set the different weights for all of my H1, 2, 3, 4, 5, and so on. Same with the normalize. You can include, same with the resets. You can include normalizes just as a CSS file within your project. I believe there are options too if you want to use it as a module or things. But as a base level, they are just CSS style sheets that you can include. Cool. Next thing we're going to look at is the box model. The box model is the idea that every HTML element within your document is made up of these 1, 2, 3, 4 parts. The margin, border, padding, and in here, this blue part, we can call this the content. So any tag, regardless of what it is, will have these 4 parts. Let's look at, so for instance, this page that we had up. Another useful tool with your developer tools is clicking on something. So this big H1, I can add new styles to this H1. So I can go color, red. Oh, and it's being overwritten somewhere. Right below it. And I can see the new color that's being applied. This is how I would encourage you to do iterative development with your CSS. Instead of switching back to your editor, finding the CSS document, adding a bunch of changes, coming back here, refreshing your page to see that either nothing's changed or like it didn't change in the right way, and then you have to switch back, write some changes and just complete the cycle over and over again. Make your changes or like make a guess at what the change will be first right here in DevTools and see if it works the way you can or the way you think, and just experiment. Oh, I want this HTML tag to have an underline. Oh, I can add it here. Is that the look that I want? If it isn't, okay, I'll get rid of it. I'll try something else. I want it to have, sorry? Yeah, exactly. So text, I don't think italic is decoration. So we could look that up. CSS italic text. Font style. So we'd come in here. Where was I? Font style. Italic. And so on and so forth. You can make very quick live changes and kind of toggle things on and off and get a sense of how you want your document to look before you put them in code into your project. But the thing we were thinking about was we want to see how every element here is made up of this box model. So I'm going to add a new style rule, and this is just to the whole document. I'm going to do star, which means select every element. I'm going to give it a border of 2 pixels solid. We'll do a peach puff. Oh no, that's pretty light. Pale violet red. Still kind of light, but. And now we see every single element in this document has this box around it. So I've given them a border to visualize this border section of our box model. But this text here is all in one, probably like paragraph tag. This text all here is in a tag. Here at the top, this logo, we see it's like one box made up of 2 smaller boxes, and so on and so forth for everything in this document. Beyond that, I can also, I need probably more room. There we go. If I select a particular element, I can see the margin, border, padding, and content size. While each of these 4 areas exists for every element, whether they have space or not depends on the styling. So for this header, the margin is 2 on the top, 20 on the bottom. The border is 1.997. Padding is nothing. It has no padding. And then the content is this dimensions. And as I scroll over each one of these, it lights up in the page itself. We can probably see a cooler reference with this button. So the margin, we can see the light peach color around the button. The border is nothing, so I applied a border to everything. There must be a style somewhere that's overriding my border. Padding, the padding, I don't think I can't zoom in, but the padding is the space between the edge of that element and the content inside the element. And then finally, we have the content itself. So every element has all of these values, and adjusting each of these values can help you define the layout for your page. If you want a lot of space around your element, you might add, or if you want a lot of space inside your element, you would add padding. If you want a lot of space around your element, or your element pushing away from other elements, you would add margin. Border is, in most cases, less useful. Most of the time it's used only if you actually want a visual, like, rectangle line around your elements, as I've done here. All of these guys have border. It is not used for providing space outside or inside. It's more just to do the visual line of things. So we have margin, border, padding, and then content on the inside. Here's a nice visual representation of all of those guys. Like this. So when I set the width to this guy, I can give it more padding. I'm going to link them all together so we don't have top, bottom, left, right. It's just... So my padding, I say I want more space between the maybe word that I have inside of my box and the outer edge of my box. Whether the outer edge be defined by actual line border, or maybe my whole element just has a background color. But my word will have space before it hits that edge. Alternatively, I can say I want a bunch of margin. I'm going to take down the padding a little bit so that each of these things is not right up next to the next like box or element within your HTML layout. This button has a bunch of space before this button, and this button has a lot of space before this button. One way that you can achieve that is with margin. So this previous button, margin right, however many pixels here. This guy, margin right, however many pixels. It provides like your space around your elements. So this is mostly a layout thing. There is one kind of catch with the box model. The default box model sizing is something called content box. So my question is, make this smaller. How do I determine for my element here how much total space it's taking up? Because when I'm laying out a page, I maybe want to know, okay, I'm designing for a 1200 width. I want one box to take up this much pixels, one box to take up this much pixels. I have a bunch of values now that we're seeing that makes up this box model. How do I get like a total width? I have a padding, I have a margin, I have a border. I also have the dimensions of the box itself. So what would be your guys' guess on how you get the total width of an element? Oh, cool. So the comment here in Vancouver was maybe there's a property, a CSS property, where you can just set maximum width, and it can't be any bigger than that. What happens if my maximum width is like 500 pixels, and then I slam the padding to be like larger than that? So that might be something we have to think about. Content box, the way that content box defines how your max size is to take your width plus your padding plus your margin and get a total width value. In general, when you're talking about the size of an element, you exclude the margin. So the margin is the space around the element itself. If we wanted to calculate the space that it also included, we'd also add the margin. But when we think of, at least when I'm talking about the width of the element, I'm talking from edge of this border across to the edge of this border. So I've set the width here, we see, to 280 pixels. The height, or we're not thinking about height right now, but the margin on all sides to 50 pixels, and the padding to 60 pixels. So our total width is now 280 plus 2 times our margin, because we have a margin on either side, plus 2 times our border width, and we get a total width of 420. So that's one way to have us calculate the total width of our thing. Can anyone think of a reason this would be kind of tedious? Yeah, so the comment was we have to design for every screen size, so it's maybe not responsive. Another thing is, like, if I'm just thinking about my page, how do I say, okay, I want this new box I'm making to take up 400 pixels? What are the calculations I have to do to now make my box be 400 pixels? I can't just go and set, like, if I just go and set the width to, let's see, 400 pixels, my total generated dimensions is now 540 pixels. So I need to do some internal math to think, okay, I want my box to be border to border 400 pixels. I need to think, okay, what will my border be? What will my padding be? And then what will my content be? And I need to make it so that all 3 of those values now add up to 400. Okay, not so bad. I make one element like that. If I want 3 of those boxes, I just put 3 of those boxes, keeping all the same values. What happens if I want, like, what happens if I want, like, 3 columns or something? I want a layout similar to this. But instead of them all being uniform in content, the middle one, I want to put a big image in there. And because the image is different than a big block of text, I want this image to take up the entire box. Or maybe I just want it to have a much less padding than I do this first box and the second box. So my image is in here. I now can't use the same styles for all 3 of these boxes. I need to do a whole new set of calculations accounting for my new image, which is going to have less padding, which will have now more content width, and so on and so forth. The fix around this is to use a different type of box sizing model called border box. And border box says, okay, I don't want to have to do calculations as a designer or as a developer. I want to be able to set a single value and have that represent the width of my box. So if we set the box width here to be well, we'll just do 380 pixels, then the total generated dimensions of our box is now 380 pixels. This is kind of like the option that you said at the beginning. So our total width is 380 pixels, and then padding we have control of, and margin we have control of. We do not have control of this content size. This is a byproduct of the total width, the padding, and the margin. So we can't decide, oh, our content should be 100 pixels with one number. We would have to do some calculation there. But that is far better than having to calculate the entire width of the box, because you don't often care about the content width. You more often care about the entire width of your box. So all that to say, anytime you're doing a project, just make sure you do like a star for all the styles, or for any like thing that you're doing, set the box sizing to border box. So back in our example here, we might just go new style, everything, box sizing, border box. And I'm sure for these guys, they already had that in place. This will make it easier for you to calculate things. there isn't really a use case for using content box. So this is all to say it's probably just an initial step when you start up your project, just to remember, okay, I'm going to use border box sizing, and then I can just set the total width or total height of any element that I create. Cool. We're going to take a break in a second here, but any questions on border box or just box model for CSS in general? Thinking about when you would use these different values, or like what the purpose of them is. Any questions there?
Other than if you have a border, is there any other reason why you would use margin over padding or vice versa?
So the question was, other than when you have a border, is there a reason to use margin versus using padding? For sure. Often, like the elements that you have, even if they don't have a border, might have some type of like background color. They might have, like here we have this like gray box that represents the thing. So everything inside of the gray box, the spacing in here would be padding, and the spacing outside would be margin. The other place where it comes into play is margin is the space pushing against another element. So you can have interesting margin things when you have like margin bottom, but you have nothing to like push against it, if that makes sense. But if for example, this square here did not have a gray background, whether you used more margin or like you did some of this with padding, probably wouldn't make a huge difference. Yeah, if I think of anything else, because I think there's a few more considerations taken into place, but I'll think on it and I'll bring it up after the break. Any other questions? So the question was, are we going to learn about Flexbox today? We're not going to look at that today. I'm going to like touch on it briefly at the end about just what it is and what it replaces in terms of what we're learning about today. But you will have a dedicated lecture to not just Flexbox, but it comes in the responsive design lecture, which is, again, I think it's Thursday or Friday. You'll get a look at it more. But Flexbox is like an awesome tool, so good question. Sweet, we'll take a 15-minute break, come back at 11:17. And yeah, if you think of any questions during that time, bring them up at the end and we can jump into them. All right, we're gonna get started again. So if anyone had questions that came up over the break, let me know. The one that we talked about right before we broke was if we don't have an actual border, like in this case here, where we can see a line, or maybe like a background color to define the difference between outside of an element and inside of the element, doesn't matter between padding and margin. The one thing I said was one difference between the two is a margin is pushing against other elements. And what I mean by that is if we take these three lines here, so we look at each one and they have the blue content and the orange margin. Margin is the space until the next element, but margins don't stack, meaning each of these elements has a top and bottom margin. So if I set the top margin to be 5 EMs, so now we have really big top margins. If I then set the bottom margin to be 3 EMs, I don't see a change in my layout because while this element has a bottom margin of 3, this guy has a top margin of 5. So 3 units of personal space is within the other guy's 5 units of personal space. So it doesn't change the spacing between these two of them. Margin just takes into account exactly the space between me as an element and someone else. And if it is over or equal to my margin value, I don't care. Meaning you don't stack margins because this element has a bottom margin of X and this element has a top margin of Y. It's not X plus Y, it's the greater value of X or Y. In our case, top margin being 5 is the greater value, so the space between these two guys is 5. That can be helpful because we take all these guys and we're stacking them, and we just want to say a uniform space between them or a minimum space between them. If I put another element down here and I don't know necessarily what its margin will be, it prevents us from having just really big spaces when you didn't necessarily want really big spaces. If we had done all of this spacing with padding, they would be added. So if I go padding top, padding bottom, we have the top padding and the bottom padding both taking up space. They're not collapsing, as you would say, and there's a lot more white space to this document. The other small thing is you can do something where you go margin. I don't know if it'll work here. Margin auto will have the element take up the extra space automatically. It's most noticeable if I give this a width of, say, 200 pixels. Margin auto is one way to center an element. I'm saying there's a bunch of free space on your left, there's a bunch of free space on your right. Automatically take up a proportionate amount of that left and right space. If I untick margin auto, they just now have some artificial margin because all that is free space.
For the margin auto to work as to work to help center the element, do you also have to add the width?
So the question was for the margin auto to work to center the element, do we also need a width? The reason I added a width here is because without the width in this case, these paragraph tags are 100% width, meaning they have no left and right margin. I'm making them smaller than their parent element so that there is room to add that margin. So sometimes, yes, you will have to enforce a width on something in order for it to have the margin auto, depending on that elements with in the first place. And that actually segues us nicely into our next topic, which is thinking about block versus inline elements. Just like every element in your HTML document is going to have this box model, every element in your document will either have the block or inline property. So block level elements, they start on a new line. They take up as much space as they can horizontally. They're structural elements, meaning they're elements that like build the structure of our document. So things like divs, all of the H1 through 6s, paragraph tags, UL tags, which build up a list, nav tags. And then conversely, inline tags, they don't start on a new line. They don't affect elements around it. We'll look at what that means in a sec. You can't set the width or height of an inline element. They're not structural. So they're not taking up space the same way a block element will. Most inline elements are content related. So spans, link tags, inputs, buttons, images, all things that directly contain content tend to be inline elements. So I have another small demo for us. This one is, we have block HTML and get that open, block CSS. Just get rid of the other demo. There we go. So our block HTML, again, just a very simple skeleton HTML document with one font that I'm importing, one external style sheet, and then in the body, where all of our HTML content goes, I have a series of spans being inline, and divs being blocks. I have no classes, no IDs, but there is content inside of the spans and the divs for the most part. I'm going to comment. Actually, this one is a nested one, so we'll look at that in a second. But right now, without that commented one, we just have a span, a div, a span, and a div. And the CSS, I have some CSS for the span and some for the div. This is not affecting once I delete that, so this was inline and block are changeable properties for CSS. So I can say span is normally inline, but I want to make it block. But we want to look at the defaults to start with. So let's just say our span will be inline, our block will be, or our div will be block, and I'm just adding some color so we can distinguish them from one another. So this is an inline element. This rock is our block element. And this is, again, another inline element. When we go inline, block, inline, it's very hard to distinguish them one from another. But if we jump back into the HTML and I stack a couple inlines, so we'll do 1, 2, 3 inlines, and then I'll stack 2 blocks to compare. They're going to look a bit different. So inline elements, this is the first inline element, followed by the second inline element, and the third inline element. They come in line. Each new inline element does not take up its own row. It tries to flow and fit into whatever content is already there in the best way it can. Whereas a block element, one, takes up as much horizontal space as it can. Even though this following block element could fit to the right of this block element, block elements aren't having it that way. They just take up as much horizontal space as possible, and they will start on a new line. So boom, boom. Instead, a span, this is the content space that it's taking up. But we see that the second one is overlapping with that. So when I say inline elements don't really respect physical space constraints, they don't take up space in the same way that a block element takes up space. This div is taking up, here we see 300 by 300 pixels. We can still get a reading on the width and height of this element, 562 by 188, but it only comes down to like how this content can fit relative to other inline stuff. This one changes, they're all different sizes. And if I increase the size or decrease the size, they just kind of move to fit in with the rest of the content. Because inline elements are not structural and they don't take up space in the same way a block element does, I can't go on this element and give it height and width. If I set the height to 400 pixels, oops. Get the color back. If I set the height to, oh no, this was background color. Background color. And I finish pixels correctly, nothing changes in the document. If I try and give it a width of 200 pixels, again, nothing changes. Inline elements are not structural. I can't force them to have space around them. In a similar way, these guys, I can't set, like, move them around. If I go padding 100 pixels, and I spell it correctly, I do have padding because these, well, I'll give it a more sensical value, 10 pixels. So I can set padding, margin 20 pixels, and I can set margin. But you notice that the margin is kind of nonsensical in this case. A little bit of space between this end of this inline element and the start of this one, this white space increased here. But if I look at the element, it's telling me that there's just a margin here. Because the way this element takes up space is not directly represented by its box model. But in the real world, we don't just have simple inline and block elements. We have combinations of the two of them. So I can have, no, let's not look at that one. I can have a inline element inside of a block element. So this is our block. That's our inline element. What we notice here maybe is that our inline element is overflowing outside of our block element. When we have this overflow happening, any of this inline's content that is outside of the box is kind of just disregarded in terms of respecting its space. This div is taking up the same position and space as it would even if this span was not there. And this makes sense that we can do this. The whole container, the body of our HTML document is kind of like a block element. A block element takes up space, and if we put something that doesn't take up space inside of it, that doesn't really have any logical problem. The problem comes where if we want to take a div and put it inside of a span. So span, we just said will go inline with other things. We can't set it to have a strict width and height. It won't take up full horizontal space. And then a div is like kind of the opposite of that. We have a specific height and width. It's going to try and take up horizontal space. So by putting a div inside of a span, we have a conflict. What will this element or this combination of elements look like? Will it take up full horizontal space, therefore kind of breaking what a span should be doing? Or will it take up only part of the space and not be able to have a width and height, therefore breaking what a div does? What it does depends on the browser. So in our case here, is it this one? This is our div inside of our span. So they kind of just end up being placed next to one another. And this is the best case scenario. In some cases, it just will not render. And because of the conflict between the two, as a general best practice and actual like syntactical rule in some cases, you do not want to nest a block element inside of a inline element. The two are just not going to get along. So inline elements and block elements can go inside block elements, and of course you'll have to get any sort of complexity to your layout. So do that as much as you want, but just be careful. An inline element, you don't want to put a block line element inside of it. And just lastly, before we finish, we can why are you doing that? You can override the default display. So we can say, all right, we want a span to be block instead of its default inline, and we want to give it some height and width. And you will be able to do that. We're getting a lot of overflow here. Maybe I'll give it a 100% width. Cool. Any thoughts on block versus inline? You're going to be using block level elements majority of the time. Just keep an eye out for inline ones and make sure you have a kind of somewhat understanding of the difference of the two, because it can affect your layout and give you some weird things. This is just what we said. You don't want to put block elements inside of inline, but the reverse is completely fine and necessary. You can overset it. Okay, so now we get down to kind of one of the most important parts of this lecture, and the question that came up before in a couple places. How do we decide which style wins out over another style? When two competing styles are applied to an element, the one with the higher priority specificity gets applied. So when we say specificity, we're talking about this sequence of numbers that we can assign to any element within the DOM. This sequence of numbers is the count of how many inline styles are there for that style for the element, how many IDs are there, how many classes, and we don't have to worry about pseudo classes for now, and how many elements are there. Meaning, when we look at two selectors, so selector 1 and selector 2, for a competing style, both of these are trying to set the color, we can determine which one will be applied by, I like to think of it just the bigger number or the bigger specificity. So this first selector has one ID. This selector has one element and two classes. So the first one ID, we'd have 0 inline, 1 ID, and 0 and 0. A 0, 1, 0, 0 is kind of like the number 100. So we have 100 versus the second one, which is 1 element and 2 classes. So 1 element, 2 classes, 0 inline, 0 ID, 2 classes, and one element, so 21. 100 versus 21, the bigger number is going to win. So we have the color red winning out. And that's exactly, well, kind of similar to what we have here. A style with 2 classes, 1 element would be applied over a style with 1 class and 1 element tag. This being our 2 classes, 1 element with a score of 21. Our selectors can have IDs in them. They can have classes in them, and they can have elements in them. Our selector cannot have an inline style. And an inline style is not like, I can't go in here into my selector, for instance here, and add somehow inline style. The reason that shows up in the specificity chain is that inline styles just beat everything else. If I have declared something inline in my document, if I go span style equals color red, for this span, its color will be red. This is like the trump card. This is like the strongest CSS warrior. It will beat any number of IDs, any number of classes, and any number of elements. The one difference, I guess, between this and a real number is one ID will beat 20 classes. Like, there's no rounding up. It's not like, oh, some number of classes eventually becomes more powerful than a single ID. One ID is more powerful than as many classes as you want. It doesn't matter. So let's look at this for a second, kind of get an idea. We have inline, ID, class, element. Try and memorize it as best you can, because we're going to do a couple battles after this. So we looked at this first one. What about this one? Which style, red versus blue, will be applied in this case? Blue, so we got 1 vote for blue. Any other thoughts? There's no risk if you get it wrong. You just learned this, so no one will be judging you. So we got another shout of blue. I don't know what you guys in Calgary are thinking. Cool, so let's calculate it. The first one, we have 2 elements and 1 class. So 2 elements and 1 class is like a 12. We have 1 class, 2 elements, so we get a 12. The second one is 2 classes, so it's 20. 20 being the higher specificity, we would have blue winning out. What happens though in this case? So we have identical styles. We can calculate, or not identical styles, identical selectors. We have div, box, and left. So we could calculate the specificity for this one. It would be 1 element, 2 classes. Again, 12. But that doesn't help us. Which one will be applied? So in the case of a tie, the rule is the last style to be read in the document. Meaning, if these are in separate external style sheets, so we have block CSS, and then I have a second one, block 2 CSS, the style that appears here will win if given the same level of specificity. So style 1 is loaded. It's written, the whiteboard's not here, but it's kind of like if I write a style down on paper and then something else comes in, you overlay it on top. the last thing you write on top is the one you see. The same thing with styles. So this one will win out given equal selectors. The alternative to this, we can also have the same style in the same CSS page. So take this, paste it right below, change these like values. So now both of these are single elements, so like a really low specificity of 1. But which one gets chosen? In a document, it's the same thing, the last one that was read, so this bottom style will have preference over this style. This doesn't mean that all of these styles will be applied over this one, because if I don't have a color here, it will still take in the styles that it can get from this first selector and then just only override the specific properties that show up in this one that are different. There is a couple other tools that can help us with specificity. So we calculate the specificity in this way. The first thing to think about is IDs have higher priority over classes. So that is one way. We looked at the difference before, but this is another difference and another way that IDs can be useful when we're creating styles. In general, you really want to be light-handed with IDs. Because if you're putting IDs everywhere, you now have a bunch of really strong stylings that are going to be hard to overwrite. You also have those restrictions on IDs that each element can only have one ID, and each ID can only be used in one location. So IDs are not the greatest thing to use for styling purposes unless you have a specific thing in your web page that you want one version of that. If you are deciding on any like general case styling for something, most pages like this is a link and they're the same throughout the document. This button looks the same throughout everything. If we styled this button with an ID, we'd be in trouble. We can't have multiple buttons. That's one reason to be light on the IDs. The second one is, again, they're so powerful that if you make everything IDs, you're going to have the case where you're looking through here and you're seeing a lot of like, oh, I just added a new style and it's getting crossed out because I forgot that I once added that ID somewhere. So you have to think about when are we being too specific? So here, this is a valid selector list. We're saying divs that have a parent, or no, okay, let's think. We'll start from the right. Any element that has the ID home, the class underline, the class link, and is a element that is the first child of a paragraph tag, that is a child of an A tag, that is also a child of a div tag. So way too specific there. In general, you want to be like as least specific as you can while still correctly targeting the thing you want to change. So if we're changing a link somewhere, and we have one div above it, and we know that for all links inside this div, given this class, we have 3 things, only include those 3 things. You don't need to be more specific. So here, I have a link tag that has the class link. If this was my CSS, my selector would be a.link. I wouldn't have to be any more specific than that until I needed to be. In the second case, I have no class. I could just say, in general, I want all of my link tags to have a specific style. I can just select it by A. start off general, and then if you find later that you don't want that style applied for specific A tags, add on extra selectors after that point. There's one last thing you can do for specificity, and this is important. If you have a style and it is not going through and you just want to force it to be the style that is selected, you can apply this important keyword to the end of that value. It'll move the style to the top of the specificity hierarchy, but this has the same problems with IDs. If you make everything important, then like nothing is important. If you're using important too many places, then what happens when you want to override an important style? You're just kind of out of luck. In general, like the rule should be like don't use important. And then if you absolutely are forced to, like you can't find any specificity list, or your specificity list starts to get like really ridiculous, like this one we saw here, you can throw on an important. Some people like to like restrict themselves and say, okay, for this project, I have like 4 uses of important, and that's my like cap. I'm not going to use more than 4. The case where this comes up, I see people most often using it, is when you're importing external CSS libraries. So we haven't gone over that, but one you might have heard of this point is something like Bootstrap. It's a whole chunk of CSS styling for like common things like buttons and imports or input forms to make them look nice, so we don't have to do a bunch of repeat work. You include that, but then you're like, hey, for this one button, I want it to change a little bit different. And you try and add your style, but it doesn't apply because this big external style sheet that you've already included has a different rule applied there. So that's a case where sometimes it's okay to throw on an important and say, I don't know how it's done in Bootstrap, but I really want the color to be red in this case. Those are like, we're at the point where we've hit all of the important things. There's 2 other things we can think of. One is looking at floats. The other is, we'll touch on this regardless. The other is thinking about position. I'm going to blow through float, and I'll explain why, and we'll see how far we get on position. So float comes from this idea early on in web development that web pages are like digital newspapers or digital magazines. When the web started first coming online, people looked to like web pages and they said, oh, this is the only thing similar we have here is other media forms like newspapers and web pages. And a lot of early sites, and still today to some degree, looked like magazines and newspapers, or in a lot of cases very poorly done magazines and newspapers. And so different principles and things within CSS come from this idea, float being one of them. Actually, the box model is another thing that comes from like print and was borrowed from print and like magazine development. The same things apply when we're thinking about print and newspaper layout, and they use the same terms of margin, border, padding. So we directly lifted that from that medium. Another thing that was introduced is float to accomplish another pattern that was seen within newspapers and magazines. So this big graphic here, the putting the band back together, these images here, often within content, you have blocks of either images or other text or media that you want text or other content to flow around. So this image has text wrapping around the side. These images have text kind of wrapping around them. Maybe not the best example, but you have blocks of things and you want the content to flow around it and continue. Float is the attempt to bring this into web development, into websites. Again, let's look at an actual example of floats. So float allows inline items to wrap around them. Float stuff does not take up vertical space in a div. We're going to need to adjust that CSS in a second. But we'll open it and check what it looks like. So there's our CSS. There's the HTML. Our HTML has one external style sheet, the one font, and then we have a couple divs that are to illustrate different float scenarios. Each div, external div, I've given the class of ocean. And ocean has this light blue background. Inside the ocean, we have one or more boats. And the boats sometimes have the property left, sometimes right, whether they're going to float left or right. This is a clear. We'll look at it in a second. For now, I'm going to comment it out. And then I have another class called ship that just has a bunch of text inside of it. The ship's background is the darker blue. So if I refresh this, this light blue is our ocean. This, maybe not, I guess like grayer blue is our ship. And then these are all boats. As we can see, these boats are floating left, and if I change the size of the screen, they adjust to allow for the content to take up as much space as needed. In this like mid-range here, we have boats, but the content is wrapping up. If I reduce the size and make it really big, the text actually has room to float up the side of it. Unlike block elements, they're going to pop down when they can and will reside with other floated elements beside them. But unlike inline elements, something that I floated, I can give it a width and a height. I can also float stuff left and right. So these two boats are floating left, this boat is floating right, and the text and content of this page will wrap around it as best it can in this case. So we get all of this situation happening. So this is what float was designed to do. It's designed to say, you have some things, you want some text in most cases to like kind of fill the empty space around it. We want this like magazine layout, so that's what we're going to try and build. The problem is, as web development like evolved and progressed, one layout started to be less similar to like magazine layouts, and people wanted a way to position elements, left aligning, right aligning, the different things that float kind of did, but they didn't care about this whole like text content wrapping around it. If I just want to take a boat and put it on the left side, or a stack of boats and have them stack when they can, and go vertical when they can, that's just nice for responsive design, right? This accomplishes a layout of this size and a smaller size because we get them popping down. The problem is floats were not necessarily designed just for that responsive layout, so you have some problems that arise when you use it that way. For one, this is the space allocation of our boats, but they're not pushing down the space allocation of our ship. Meaning, our ship starts from the very top of our container all the way to the bottom, and our boats are floating on top of the space that our ship takes up, even though they're elements that come before the ship in our HTML. So we go boat, 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 and then ship. It here looks like, well, the ship comes first because it starts taking up everything, and then the boat pops on top. So that can be annoying. One way of solving that is to use a clear. A clear says after these boats, don't let any of that like wrapping occur. So we get, this is maybe how we would more predict to understand a couple block elements and then another block element, but we still get the popping. Another solution to this kind of like problem where we don't want the two elements to overlap is to use just something else. You can use inline block, which is another display property that allows elements to take up, or kind of jumping all over the place, to go inline when they have the space, and then collapse when they don't have the space. You also have Flexbox to solve a very similar problem, and that is kind of the modern day solution to float. You might, throughout Tiny or Tweeter, use float in a few cases to like justify stuff left or right or get space, and that's fine. But the tendency is to use Flexbox nowadays because of the weird problems in terms of space that float can cause, like this situation here. And this isn't bad. It's just specifically designed for this, or that magazine style of layout that we were looking at. So this type of stuff, if we're not doing that, there are some weird things that can come up with floats. Cool. We just touched on Flexbox. It aims to correct some of the frustrating parts of both the box model and like tools associated with the box model like float. Flexbox is new, but at this point is like super supported. So globally, Flexbox has a 95.82% complete support and a 3.18% partial support, leading to like 99% coverage. That's like amazing, unless you're developing for like some ancient opera or discontinued Internet Explorer and Opera Mobile. There's also a couple other new native CSS features. So Flexbox is something built into CSS now. It's not like an external library that you need to import. Similarly, CSS Grid is built into CSS now, and it lets you define grid layouts. It's not something we looked at, but it is a common thing throughout CSS and web pages. How do you lay out a page having many columns and rows so that it is adaptive to responsive designs? If I shrink this page horizontally, how do these boxes move and adjust? CSS Grid helps with that. It is also fairly supported, but it is newer than Flexbox, so it has a bit less support. We're hitting a 91% or 93% at least partial coverage. Both of these are, Flexbox will be addressed in a lecture, CSS Grid will not, but they're both things that you should like start to practice with and kind of probe the waters to see how they work. Cool, I know we're out of time, but I'm gonna show one last brief demo. We won't get a deep dive of it, of just the different position or the position types that you can have with CSS. So position is a property, just like display was and some of the other things. There are a couple different values you can have for it. You can have a static position thing. This is the default for everything. Any element by default will be statically positioned. The other options we have are relative, absolute, fixed, and lastly, a bonus spicy one called sticky, which doesn't get used a lot, but is cool if you have the very specific use case that it can be beneficial for. So, all right. So the first basic one, number one, was static. Static kind of doesn't need to be explained because it just appears where it should in order of the elements that you have put into this document. So our HTML for this page, body has a border around it so we can kind of clearly see it. Or sorry, container within the body does. Box 1 is the first thing to appear. It is a block element, so it takes up its vertical and horizontal space, 200 by 200 pixels, and takes up the whole line. The next element I have set to be relatively positioned. Relative versus static are almost identical. If I just position something relative and I don't add any additional styles to it, it will look exactly like a static element. It appears, next in line in its place. If it's inline, if it's block, it behaves the way it should. The only difference between a static and a relative position element is that I can tell it to be nudged or moved in either the X or Y direction. So I can say box number 2, relative to where you would normally be, I want you to be 200 pixels down. Or relative to where you would normally be, I want you to be 200 pixels from the left. You give it a top and left, again, relative to the space that it would normally be taking up. You'll notice though, when I move this box, it doesn't affect the layout of, say, box number 4. Whether this is here or here, or here or here, 4 is not changing. To all other elements within your page, the relevant box or relative box is still in this exact position here. So everyone else is like, hey, box 2 is there, but to box 2, it thinks of itself down here, and that's where we see it. But the space that it takes up is this. So sorry, we're going to run through, look at the next one. I'll keep this one to the left a bit, or to the right a bit, so we can see. Next, we have one. Actually, I think this is just static as well. So this one was more to show that changing 2's position won't affect the next box in line. The one, this guy up here who's kind of obnoxious and following us, this one is fixed. So position fixed. A fixed element is relative to your viewport. The viewport is, the top left of your screen down to the bottom right of your screen, and vice versa. We're looking through the viewport at our site. So while our site is a long page that we scroll down, the viewport is always, from here down to here. So if I leave my cursor at this spot and I scroll, the cursor stays in that spot relative to the viewport. Similarly, this fixed box stays in this spot relative to the top right corner. It is always, this distance from that top right corner. And when you give it a top and right position, it is relative, again, to the viewport. So if I want to be in the top left corner, I could go top 0, left 0, and it's going to pop over there. If I want to keep it right, but maybe 30 pixels from the right, we get there. These are, you see them all over the place as static nav bars. Maybe nothing we looked at had one. But Tweeter, we saw Tweeter, I don't know if it's still open. Here we go. So this nav bar at the top here is fixed. It follows us as we go down. Lastly, we had sticky. And sticky is a little bit harder to set up because we need more elements to demonstrate it. But I'm sure I can find sticky, a demo. view this on CodePen. So sticky is a combination of fixed and like static or relatively positioned. So this header is static up until it hits a certain distance from the top of my viewport. So it stays there. When I hit the bottom, it starts to come with me. And then the other thing it will do is if this isn't a great example, I guess, but if I were to hit, like scroll past this green div, it would be left behind. So you can have the effect of like trailing headers. If we had, oh, we might be able to do it. Let's just copy this a couple times. So the header follows us, and then it gets left behind. The next header follows us, and it gets left behind, and so on and so forth. So it's a very specific use case, and you won't be using sticky outside of wanting to do something like this, but it's just your last and like bonus special option for positioned elements. Cool, we did it. Lastly, frameworks. Again, this is something I would encourage you not to explore right away, just because we want to get a nice understanding of the basics of CSS and get comfortable with all these properties. Frameworks can be like great resources later on because we're not all designers. We don't want to have to be like remaking the same button for every project. We can just pull in a framework and say, or a front-end CSS library and just say, style this button the standard way, and we don't have to go and think about CSS. But for now, that would kind of be against the point because we want to learn to be able to do a lot of that ourselves. So probably don't use this now, but in the future, you might get a lot of use out of it depending on how much you end up liking CSS. Any closing questions before we kind of finish up? There's a bit of extra stuff in these notes. So when I send them to you, you can give a run through and touch on some extra stuff. But we covered the meat and bones of it. Calgary, if you guys have any questions before we finish off, just throw them up in Slack. I'll field a couple here, and we'll wait a little bit to see if anything came up on your end. So the question was, in our boat example, which was for floats, the ship and the boats were both in a div, but our boats were kind of able to override their block property. So let's look at it. So here, our boats are block. Like, I didn't override them or anything. Their default is still block. But they're not behaving block-like exactly because float is telling them to override some of the blockiness that they have. One of the blocky things they're overriding is more than one of them can appear on the same line. The other blocky thing is that they're just not respecting the overall layout of the page. And that's where we see, this ship div that follows them is just like not respecting their personal space at all, and it's just taking up the top of the thing. Cool. Any other questions? Sweet. We can leave it at that then. I'll give you the notes. There's also these small demos in the notes. So if you want to just like poke around and kind of change values in your inspector, that's the fastest way to me that you'll learn CSS, is just to like have a basic layout and say like, oh, what happens if I come in here and I grab only this boat and I tell it to float right instead? Oh, it does that. Small changes, small like experiments that you can do on the DOM will really help to build your understanding of how CSS is changing the different things. It'll also make it, sometimes I find you can put a bunch of changes in here, like oh, I'm going to do the margin 10 pixels, then I'm going to do this next thing, and you write a bunch of CSS, and you pop over here, and like just havoc ensues, and everything changes. And it's really hard to debug and like, kind of pick apart which change in the bunch of lines of CSS that you did just broke everything on your site. So small changes in the inspector, really helpful, especially early on. Sweet. Thanks, guys. As always, I'll be around and available on Slack if you have any questions about any of this stuff.